Okay, so I'm on the third page of the Similarity and Congruence Unit Review, Day 1. I'm going to do this one. I'm going to do just pages 8 and 9. I mean, questions 8 and 9 on page 3. I'll zoom in. Okay, so question 8 says, given Q lies on PR and S lies on RT. Okay, so that's all we know. What proves that triangle PRT is similar to triangle QRS? I'm going to draw the separate triangles. People are getting tired of it, but, you know, this is how you avoid making silly mistakes. PRT, there's my big triangle, and then I've got this little triangle, QSR. Well, I know one thing already, right? I got a pair of angles that are congruent. R and R. It's the same thing, right? Same angle, so it's congruent to itself. What do I need? Well, I either need another pair of angles or a pair of proportional sides, okay? So, let's look at my choices. First choice is PQS is congruent to TSQ. So, PQS. Well, that's not going to work because PQS is not an angle in either of these triangles, right? It's right here, but that's not in one of the two triangles here, so that's not it. PTR is congruent to TPR. PTR, okay, that's right here, is congruent to TPR. Well, those are both in this triangle. That doesn't tell me anything about this triangle, so it's not going to tell me that the two triangles are similar. Move on. QS over PT equals QR over SR. So QS over PT, okay, equals QR over SR. No, wait a second, that doesn't make sense. Because QS over PT, good. Then we've got QR over SR. We should have Q over R over PR. That would help us, wouldn't it? Okay, so it's not this one. So it should be D. Let's just check. QR over PR, okay, equals SR over TR. That works, right? This side over this side over this side. So D is our answer. Question 10. All right. Triangles ABE, ADE, and CBE are shown on the coordinate grid, and all vertices have coordinates that are integers. Okay, so here's my thing here. Which statement is true? So we're trying to figure out which statements. Our statements are all about which triangles are congruent. So what we're trying to figure out is what triangles are congruent. There's a couple of different ways we can do this. We can do it with finding the lengths of the sides of the triangle. So the triangles that we're looking at are going to be ABE, ADE, and CBE. So ABE is right here. ADE is this one down here. And CBE is this one. So there's three smaller triangles. They certainly look congruent. And I'm going to say they probably are congruent. And I can do it a couple different ways. I think the easiest way is going to be to use side, angle, side. I'll show you what I mean. Side, angle, side is going to say that, well, these sides, first of all, let's talk about the angle. Well, basically, I know that I can look at these two. They look like they're perpendicular. It looks like they make right angles. Well, if they're perpendicular, then the slopes of BD and AC should be negative reciprocals of each other. Well, are they? Let's check. Slope of BD is going to be, well, go from B to D. I go down 4 over 2. Negative 4 over 2. Negative 2. The slope of AC, well, to go from A to C, I go, what, up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So up 4 over 8, which equals 1/2. So yeah, those two, oops, negative 2 and 1/2, those are negative reciprocals of each other, so the lines are perpendicular. So BD is perpendicular to AC. That means that these are all right angles. So I've got angles, all right. What can I use? Well, with right, oh, you know what? Actually, I won't use SAS. I'll use HL. That'll be even easier. I need to know then that the hypotenuses are all the same length, and that the at least one leg is the same length. I got BC. I can figure out how long BC is easily. 1, 2, 3, 4, 5. So that's 5. To figure out AB, I'm going to have to use the Pythagorean theorem, right? So I've got 1, 2, 3, 4 on this side, 1, 2, 3 on this side. 3 squared plus 4 squared equals c squared, right there, yeah? And so I've got 9 plus 16, 25, so c equals the square root of 25, which is 5. So look, I already have that AB, and now I also know that BE is congruent to itself, right? So I've got my hypotenuse, I've got my leg is BE, so I already have that ABE and BEC or ABE and CBE are congruent. So I've got ABE and CBE, so it's either B or C, and now D looks like it's the same. Let's just check. Well, the hypotenuse is 1, 2, 3, 4, 5. Okay, so the hypotenuse is 5. We just need the length of DE. Okay, figure that out. We've got, well, it's down 1 over 2, or down 2 over 1. If you look at BE, it's also down 2 over 1. So you're going to have two triangles, right? 2, 1, 2, 1, two right triangles. If I do the Pythagorean theorem, I'm going to get the same thing for C as I do C on both of them, right? 2 squared plus 1 squared equals C squared. 2 squared plus 1 squared equals C squared. I'll have the same answer. So that tells me that the sides are congruent. So all three triangles, that's a long-winded way of saying all three triangles are congruent. Last one, number 10. One triangle has sides measured 6, 8, and 10. A similar triangle has lengths of 15 and 9. What is the length of the third side? This is a little confusing because 6, 8, 10. We get that. 9 and 15, it's not clear if the 9 is the shortest side or the middle side. 15 could be the second side or the longest side. I'm going to assume that 9 kind of goes like this. And we're trying to find, so 6 goes with 9, 8 goes with 15, and 10 goes with x. So 6, wait, does that make sense? Oh wait, we can't figure this out, right? We should be able to figure this out because the ratios would have to be the same. So 6 over 9 equals 2/3, or 0.67. 8 over 15 equals, well, it doesn't equal 2/3, it equals 0.53. So 8 can't go with 15. So it must be that 10 goes with 15. Let's try that. So 10 over 15. Yeah, it's 0.67. So we got 10 over 10 goes with 15, 6 goes with 9, 8 goes with this side here. We know that all the ratios are equal because the triangles are similar, so we can just set up where 8 goes with x, and then we can choose either other pair, so 6 and 9, 6 over 9. So I get 6 times x equals 8 times 9, so 6x equals 72. And so x equals 72 divided by 6 is 12. So the third side is going to be 12.